Hello everyone, welcome to my channel. It's a 8th day of 30 days of code, and let's look at the problem today. Today we have here classes dealing with complex numbers. Let's see the problem. For this challenge, you are given two complex numbers and you have to print the result of their addition, subtraction, multiplication, division, and modulus operation. The real and imaginary precision part should be corrected up to 2 decimal places. Input format: one line of input, the real and imaginary part of number separated by space. So this is gonna be the real part and this is gonna be the imaginary part. Likewise, first number, second number. Then what we have to do for the two complex numbers C and D, the output should be in the following sequence: on separated line C plus D, C minus D, C star D, like multiplication, then division, modulus. So the output format should be addition, subtraction, multiplication, division, modulus, like that. So then they have also mentioned some cases for the complex numbers with non-zero real value and complex part. The output should be in the following format. Like that, say they have mentioned some things over here. So let's look at, they have already provided some codes the input format. They already took the input, then already taken the input, then they mention the instances of two objects, then the class is already declared here, then the methods of class that we only need to fill out. Method means the functions associated with the class are known as methods. So here addition, subtraction, define, add, subtraction, multiplication, these are all methods of this class complex. Like if you guys don't know about the classes, then go and search it in YouTube, like object oriented concepts of Python. Like there are a huge number of videos over there. We actually use classes to logically group the data into functions so that it's easy for us to use again and again, like that. And these are the attributes of the classes, real and imaginary. So we need to call it again. So let's do that first. Self dot real equal to real itself, self dot imaginary equal to imaginary. Okay, we are done with that part. Then we need to add the objects over here. So self and number, so this is going to be C and D. Then like first I'll show you how a complex number looks like. This is a photo that I got from the QMap website. I will add the link in the description so that you can learn more about the complex number. So it is defined by z equal to x plus iy, and x is the real part, then y is the imaginary part, and iy is the imaginary number. So like as we see over here, this 2 and I2 is going to be the real part and I1 is going to be the imaginary part. So it will be represented in 2 plus in this format, 2 plus I1 or 2 plus 1I, and both are enough. Like is it equal to, here same as well, is it equal to, this is the way it is represented. So let's now look at the addition of these two of these. So it's gonna be, first we have to addition, right? So yeah, let's look at the addition part. Let's rub it out. So here we have the test cases 2 1 5 6. Okay, that's gonna be 2 plus 1 I. This is the first complex number, and this should be added with 5 plus 6i. So when we are adding two complex number, we will be individually adding the real part first. Like this is the real part, right? This is the real part. We'll be adding the real part, then we'll be adding the imaginary part separately. So 2 plus 5 equal to 7, then 1 plus 6 equal to 7. So 7 plus 7i, this is going to be the addition output. So similarly here 7 plus 7i, that's what we got. And this points dot 00 that as mentioned over here, it should be up to 2 decimal places. That part is already done here, and all the some cases mentioned over here, it's already done as default. We don't need to do anything of any of those. We only need to complete the methods over here. So let's do that part. So this is going to be the self part, and this is going to be the number part. So in the self part, this is going to be self dot real, and this is going to be self dot real, and this is going to be self dot imaginary. Yes, okay, instead of self. And this is this part here is number dot real, this term number dot real, and this is gonna be number dot imaginary. So in order to add the complex number, we need to add self dot real plus number dot real and self dot imaginary plus number dot imaginary, so that we will get the output of the addition. Let's return it out. So return, then complex of first will be real, then imaginary. So real part is self dot real plus number dot real comma self dot imaginary plus number dot imaginary. Let's see whether the spellings are correct. Self dot real, number dot real, self dot imaginary, number dot imaginary. Okay. Okay, similar to the case of addition, when it is subtraction over here, let's change this part, then put subtraction. Subtraction, we will be doing the same, similar to the addition itself, only the change will be like we will be subtracting both of these. So here 2 minus 5, then this minus 5. So in both of the terms over there, they're going to be minus, that's all different. So just copy it out and paste it over here. So here instead of addition, it's going to be a subtraction. Here also subtraction. So that part is done. Now we are coming to the multiplication. So this is kind of a tough part. Let's rub it out. Let's take the same example itself. 2 plus 1i, we need to multiply with it. 5 plus 6i. So it's like a plus b into a plus b, similar to that way. So we'll be multiplying the 2 first with 5, then we'll be multiplying the 2 first with 6i, similar to that way. 1i with 5, then 1i with 6i. So we will be getting 5 into 2, it's equal to 10 first term, then 5 into 6 equal to 12y, then 1i into 5, it will be 5i, then finally 1i into 6i, it will be 6i square. 6i square. Here I square equal to minus 1. Since we define I as root of minus 1, root of minus 1 is known as I. So when root of minus 1 gets squared, it will be minus 1. So this I square gets removed, and instead we have to write minus 1 over here. Minus 1, right? So this term gets subtracted by this term. So 10 minus 6, 4, equal to, the final result will be 4 plus 17i. Let's see whether it occurs as the same in the output. So here 4 plus 17i, similar to that. So when we need to do that, we have to mention each of the elements first. So here we have, this term is real and this term is imaginary. So the real part, in order to get the real part, first we declare a variable like real equal to let's check for the real. So in order to get 10, this is s dot real. It gets multiplied by number dot real. So self dot real multiplied by number dot real. Then we need to get this term, right? This term will be self dot imaginary. It will be subtracted, right? This minus appears, so subtracted by number dot imaginary. So here we have minus self dot imaginary multiplied by number dot imaginary. Okay, so we'll be getting the real part. For in order to get the imaginary part, imaginary equal to, imaginary will be first 12i. 12i is self dot real multiplied with number dot imaginary. Self dot real multiplied by number dot imaginary. Then we will be adding it, right? Addition. Then this term 5i. 5i is gonna be 1i into 5. That's gonna be self dot imaginary multiplied by number dot real. Self dot imaginary multiplied by number dot real. Okay, we finally got the real, and so let's return it. Complex of real comma imaginary. Then we can move with the next part, true division. Let's check whether how we can do the division part. Let's rub it out. Okay, in order, let's take the same example itself. 2 plus 1i then divided by 5 plus 6i. So we cannot divide a complex number with another complex number directly. In order to do that, first we need to remove the I part. So for that we need to multiply it with the complex conjugate of this number. So this is gonna be 5 minus 6i and 5 minus 6i. So now the denominator is like a plus b into a minus b. Here a plus b into a minus b. It's gonna be a square minus b square. So here when this number gets, let me change the color, this term gets multiplied with this term for the b square, this I gets multiplied with I, so it's going to be I square equal to -1. So this minus gets changed to plus, so the denominator will be a square plus b square. So first we can write the denominator over here. Denominator equal to, this is number dot real, right? Number dot real multiplied with number dot real, then number dot imaginary multiplied with number dot imaginary. So square, we can use the square function. Number dot real square plus number dot imaginary square. So a square plus b square, we can convert it to float. When we do that, there won't be any i's over there. Like 5 into 5, 25. It's gonna be 25. Then 6 into 6, 36. Here the minus gets cancelled, so 25 plus 36. That's gonna be the denominator over here. So the numerator part, for the numerator part, it's like the above multiplication itself. This is gonna be self, right? Self, this is self dot real, self dot imaginary, number dot real, and number dot imaginary, but only difference is the imaginary got to a negative number, so we can just call the same function instead with only one negative. So we can do that part too. For the numerator equal to self multiplied with complex of number dot real comma minus number of imaginary. Okay, now we got that part. Then we need to get the real and imaginary part of the output. So it will be equal to, this is gonna be 25 plus 36, it will be 31, 61, right? 60, 41, 61, okay, 61 divided by 61. This term will be 5 into 2, 10, then minus 12i plus 5i, then finally plus 6, so it's gonna be 16 minus 7i equal to 16 minus 7i divided by 61. So the numerator contains a real part as well as an imaginary part. So in order to get the real part separately, we can divide this term individually, so that we can get numerator a real part like this term, a real part of the numerator divided by the denominator, say similar to the get the imaginary part like this. So we can do that part. So real equal to numerator dot real divided by denominator. For the case of imaginary, numerator dot imaginary divided by denominator. and let's return it. Return complex of real comma imaginary. Okay, we got that part too. Now finally to get the modulus. For getting the modulus, first let me define what is modulus. Let's rub it out. The complex number is actually defined in a graphical space like this. This is gonna be the real axis. This will be the imaginary axis. So when a number like 5 plus 1i is given, this term will be divided into 5 parts, like 5 1 2 3 4 5. So suppose here is 5 and this is 1 of imaginary, so the point will be like here. This is gonna be 5 plus 1i 5 plus 1i. So the modulus of this complex number means the distance from the origin to this point. So it's gonna be the straight line. So we can apply the Pythagoras theorem over here. So it will be the square of this 5 and this 1 and the root. So the modulus of this complex number equal to root of 5 square plus 1 square. So, and the real part, imaginary part will always be 0 when we take the modulus. So let's do that. So here they have already provided us the math function, so we can just use math function real part equal to math.sqrt of, we need to get the self dot real whole square plus self dot imaginary whole square. So we'll be taking first square, then real part square, then imaginary part square, then we will be taking the root of that. So we'll get the real part and the imaginary part will be 0. So we can return it out. Return complex of real comma 0. 0 will be the imaginary part, right? So let's run the code. Okay, we got the test cases correct and let's submit it. Okay, we finally got the all test cases correct too. So that's it. The formatting part is already done with the code itself. They have already done the hard part for us, so we already did the remaining thing. So I think the video is helpful to you guys. If you find this video helpful, please like and subscribe to my channel. Okay, tomorrow we can meet with the 9th day problem.